Hi there, and welcome to your PowerPoint. In this PowerPoint, we're going to be exploring Darwin's theory of evolution by natural selection. Darwin presented his theory as a set of postulates. There were three. First, he said individuals within a population have variations, meaning that they have different sets of traits. Number two, some of these variations will be passed on to their offspring. Number three, in each generation, some individuals will be more likely to survive and reproduce due to these inherited variations. This led Darwin to conclude that variations that increase chances of survival and reproduction will be those traits that are favored. Darwin supported his postulates through a set of inferences. His first inference is that there's a struggle for life. He said, "It is difficult to believe in the dreadful but quiet war lurking just below the serene facade of nature." Take a look at the image in the lower left-hand corner. You'll see it's got a serene image of nature with a man and his animals on a pasture. This is a great example of German Romanticism as an art movement, which was taking place in the 1800s, the same time Charles Darwin was writing on the origin of species. Charles Darwin was speaking against this notion of nature. It was commonly thought that nature was a place of serenity and quiet and peace, and that it was really the cities that were violent, aggressive, dirty, and noisy. However, through Darwin's observation, he said there's violence in nature, that there's constantly a struggle between life and death, and he called this a war. He supported his inferences through evidence and through theory. His first evidence he called the superfecundity of the species. An example of this is the idea that organisms tend to produce more offspring than can possibly survive. One example is baby sea turtles. You've probably seen lots of those videos where the sea turtles hatch and then they make their way to the ocean. One sea turtle can have up to 400 eggs. But of course, all 400 offspring from that one sea turtle don't survive, or else we'd be living in a world of sea turtles. Instead, about one or two of those individuals will survive out of the 400. Instead, what you will actually see when the sea turtles are born are a bunch of birds picking them off and having a nice lunch. So Darwin says, yes, there's the superfecundity of the species, and he supports this through his theory that he draws on through Thomas Malthus. So Thomas Malthus was a sociologist who was interested in human social problems. He lived in London, and he noticed that poor people in London were in terrible conditions, and he also noticed that they tended to have many children. He hypothesized that all populations, and he was particularly focusing on human populations, he said populations will increase indefinitely or infinitely, except at a certain point they'll reach a limit of that ability to expand. He called this a point of crisis. He said at a certain point the resources are going to be limited and people will have to fight or have war over those resources. So for example, people could have as many babies as they wanted until there wasn't enough food to support all those children. Then people would go to war over those food resources. The second bit of evidence to support Darwin's inference is population equilibrium. So population equilibrium proposes the idea that population sizes remain stable over time. So while Malthus said, okay, human populations are going to just infinitely increase, they'll never stop reproducing until they reach a point of crisis. What Darwin observed is that actually what happens in nature is that populations will increase until they hit what he calls the carrying capacity of the environment. and then the population will level off. They'll stop over reproducing. There's lots of ways that this kind of leveling off can happen. One example is with lemmings. With lemmings, when that live on Madagascar, lemmings are kind of famous because they are thought to commit suicide jumping off of cliffs. But what happens actually is that lemmings, when their population has reached the carrying capacity of the environment, will actually move to a new area. And sometimes they actually will jump off cliffs when they're trying to cross passageways to get to a new area. But that's not their intention, to commit mass suicide. Instead, what they're trying to do is to pioneer a new environment with a new carrying capacity so that they can continue to expand. Darwin's second inference was that populations have variable traits that are inherited. He said, "I'm fully convinced that species are not immutable, but that those belonging to what are called the same genre are lineal descendants of some other and generally extinct species, in the same manner as the acknowledged varieties of any one species are the descendants of that species." So the evidence supporting that inference is the idea that individual traits within a population will vary. And most famously, Darwin made this claim by studying the finches of the Galapagos. This image here contains the actual finches that Darwin collected while he was in the Galapagos. The Galapagos Islands are a volcanically created island range, and they're interesting because while they're so close together, they actually have very different environments on each island. And what Darwin noticed as they moved from island to island is that there were finches that appeared to be descendants of the land finch, the continental land finch, but that they had various adaptations, particularly around their beaks. And if you look at the picture here, you can see that some of the finches here in this picture have large, thick beaks, and some have very thin, small beaks. Some have curved beaks, and some have pointy beaks. And he said, this variation seems to be related to the different environments in which this finch lives. He also said these variations will be inherited by offspring. So we can see that over time, as each of these species becomes adapted to the environment that they're living in, the big beak of the seed-cracking finch or the small beak of the worm-eating finch or the pointy beak of the seed-eating finch will be passed on to the next generation. Darwin then also made his third inference, which he called differential reproductive success. He said, "A grain in the balance will determine which individual shall live and which shall die, which variety of species shall increase in number and which shall decrease or finally become extinct." Evidence to support his inference really comes from this idea of the peppered moth. He said individual survival and reproduction of individuals is not random, but the result of variation. I won't go into the peppered moth example because you have a module up ahead that's going to bring it into closer focus. In his book On the Origin of Species, Darwin presented more evidence to support his opinion. He looked at the fossil record. What he noticed is that long extinct species, such as the Megatherium americanum, which is the giant ground sloth, resemble the modern sloth, but was very giant, so a trait variation in size. You can see in the picture that they were much bigger than humans, whereas, of course, today the sloth is about the size of a cat. So what he noticed is that the fossil record seems to indicate there's a link between long dead or ancient species and modern species, but that there are variations between these as well. Darwin also looked at comparative anatomy. One of those traits that he looked at is called pentadactylism. And what he noticed is that many mammals and even some non mammals have 5 fingers. And what you can see in this image is that each of these species, both mammal and non mammal, have this 5 finger trait. So, for example, at the top left, you'll see a salamander. Next to that is a sea turtle, a crocodile, and a bird. Down below, you've got a batwing, a whale, a mole, and a human. And what they all have in common is that they've got 5 fingers. Interestingly, though, of course, they're in different shapes. Some are long, some are short. So they've been adapted to different purposes. So we've got some fingers that have been adapted to flight, and some that have been adapted to swimming, and some that have been adapted to climbing in the trees. Darwin also looked at embryology. What he noticed in embryology is that as the embryos of all species change over time, they look very similar early on, basically in the cell form here. Then they start to differentiate, yet they still look pretty similar. Eventually, it's still looking pretty similar here, and then eventually they start to differentiate even more into the different species that they'll become. And what many scientists at this time, including Darwin, believed is that the evolution or the change that the embryo undergoes as it's differentiating into the species represents or copies what the history of the evolution of that species. So basically, he's hypothesizing that about here is what one of our original common ancestors looks like between a salamander and a human, or a chicken and a human, since that stage of evolution we all sort of look the same. Darwin also looked at vestigial structures. These are physical structures that are left over from an earlier stage but are no longer useful. You can see in the image below of the whale that the whale actually has a hip bone that is no longer useful, but left over from a time when the whale walked around on land with 4 legs. You can also see in the other picture that there is this extra muscle that some people have. You can go ahead and do this activity where you place your pinky finger and your thumb together and then bend your wrist inwards. If you see the muscle popping out, then you have that vestigial muscle called the palmaris longus. This is a leftover muscle probably from the days when we were swinging in the trees, but today it does nothing for us in our hand motion and movements. So oftentimes if you have this extra muscle and you need some sort of ligament repair, then actually scientists and doctors will go in and remove that muscle and use it in other places in your body. A final thought on natural selection is the idea that it is not survival of the fittest. Many people get confused with this idea. It is true that natural selection is about reproduction and surviving long enough to reproduce. The traits themselves give you that advantage. However, you do not have to be perfect to survive long enough to reproduce. An example of this is Huntington's chorea. Huntington's disease is a degenerative disease that eventually leads to death. Now, obviously, this is a pretty negative trait, and it's genetic, it's passed on, it's inherited from child to parent, although 10% of cases are a new gene mutation. However, Huntington's chorea does not appear, and no symptoms appear until the individual is probably in their late 30s, early 40s. So you may go most of your life without realizing you actually have this disease. By the time you're 40, you might get Huntington's chorea, but you've already had a chance to reproduce at that point. And so you will have passed on that gene to the next generation. So, although there is this kind of ticking time bomb within the genes, you still have survived long enough to reproduce. The idea here is that it's not about being perfect. It's simply about surviving long enough to reproduce. And some traits are going to give you a little bit of an advantage in surviving a little bit longer. Now, the images you see here are the actual origins of the quote survival of the fittest. This comes from a social scientist and anthropologist um, who also was looking at populations in England at the time, and he said not just um, that some biological traits are bad, but he said some cultural traits are bad. Of course, we don't believe this today, but he said that the Irish in particular were a poorly made people, and that if nature were allowed to work, then it would if nature were allowed to work, then it would allow the Irish to die off. And so he hypothesized that the English had been unnaturally keeping them alive by feeding them whenever they had some sort of famine, which is what had happened until the actual famine that killed off half the population in the mid 1800s. So the Irish are famous for the famine. They survived on the potato. And again, they had had many famines before where the potato crop had failed and they had to get by. But the church and the government provided bread to get them through these times. After this theory of the survival of the fittest came out, the government said, we're artificially keeping the Irish alive and we should let them die off because if nature were to be allowed to take its course, they would be extinct by now. And so that was their policy. They decided to not intervene when the Irish experienced a famine with their potato. And within 2 years, half the population, 4 million people, had either died or immigrated out of Ireland. Now, the only reason that the famine finally ended was because British landowners, complained to the crown that they were losing workers and that they didn't have enough people to farm their land. So if you look at this image here, you'll see there's a lot of walls on the western coast of Ireland. And so what they tried to do is they said, okay, well, we're not going to artificially keep these Irish people alive. We're going to put them to work. And so they decided that after a long day working in the fields, the Irish would get some bread if they continued to build these walls. So these walls still exist today. They're made of granite stone, and the Irish call them the famine walls because they are remnant of that time when the British Crown was simply keeping them alive so that they can continue to work on their land. All right, later on in this module, you have plenty of other things to do about Darwin's theory of natural selection, so move on to those and get to know about it a little bit more.